Welcome, everybody, to the webinar about automating Dynamics 365 Business Central code quality. I'm actually really happy that I get to share this topic with you because this was the first pet project that I did when I joined Companial. It was because I joined a project where the partner had quite specific coding conventions that they wanted us to follow. For example, like all the if statements needed to be encased with brackets, all the exit statements needed to be capitalized. And those small changes really made a lot of, we spent a lot of time just going back and forward between the reviewer and the developer, fixing those small things. And that's when I started looking into how can we automate that? How can we move that before the actual code review process? But before we go any deeper into the actual topic, I'd first like to introduce myself. My name is Tina Staric, and I'm a software developer here at Companial. Now, most of the time, I do spend developing solutions for Business Central in AL, but I also love to explore what else is out there besides AL. Sometimes that's the Power Platform, sometimes that's the offerings on the Azure stack. But what I really love to do is explore how we can improve the whole development process, how we can make developers faster, how we can make developers more efficient, and how can we produce less bugs. And that brings us to the topic that we have here today. So what will I tell you today? First off, we're going to start with what is code analysis and why is it important? And then I'm going to show you what are the existing solutions. We're going to split that part into three different topics. First, what does the Microsoft provide? Second, what has the community created around it? And third, when the first two options just don't meet your needs, what you can do to create your own analyzer. And this is going to be the intro to the third topic, which is how to create a custom linter for AL. Now, throughout my webinar, I might use the terms linters, code analysis tools, code analyzers interchangeably. They all mean the same thing. They mean a tool that helps us analyze code before it ever gets to the code review process. Once we see how we can build such a tool, we're going to take a look at how it can integrate with development workflows. On the one hand, how it can integrate with Visual Studio Code, and on the other hand, how it can integrate with the build pipelines for the CI/CD. And finally, I will take you through a couple of use cases that we use here internally at Companial and show you practically what it means and how it can help the code base better. So, what is code analysis and why is it important? I don't think I have to convince any one of you why do we want to have clean code, readable code, maintainable code. But the problem is, in order to have maintainable code, we put so much pressure on the code review process. When the developer creates a pull request and another developer takes a look at it and starts pointing out, look, you missed this naming here, you made an issue here. So this is where code analysis really starts to shine. It's a way to examine source code before the program is run, before it's ever published to the Business Central environment, and before it ever gets to the review process. Technically speaking, it's a .NET library containing rules to validate source code against. So essentially, it's a bunch of rules written in C#, and when the compiler does its magic with our syntax in AL, it checks if any of those rules are invalidated, then it throws a warning. Why do we want to have code analysis? It's to increase quality, it's to find mistakes faster, it's to standardize code. But for me personally, the biggest effect was it accelerates the development cycle. I'll be repeating this quite a couple of times today. The less time you have to spend going back and forward between the reviewer and the reviewee, the faster you can merge your changes and deliver the features to the customers. How does it all work? You can think about it in the same way that we have publishers and subscribers in AL code. Anytime the compiler goes through our syntax in AL and finds, for example, a trigger or a procedure or a variable, it raises an event saying, "Oh, I found a local variable. Does anybody want to do anything with it?" So all we have to do in the analyzer say, "Yeah, oh, you found a variable. Give it to me. I want to analyze if the naming of that variable is correct." So what are the already existing solutions? I do believe most of you are already aware by the 4 COPs that Microsoft provides with every version of AL language. Those are the App Source COP, the Code COP, UI COP, and per tenant extension COP. If anybody is still not using those, I would highly suggest that you start using them because they really do improve the code. So I won't spend too much time with those, but the second one that you see here, Business Central Linter COP, I think this one is less known throughout the community. This is a community-driven initiative led by Stefan Maron, and it has, I think, 20-something rules by now that additionally can create your code more maintainable. So right now, I will first head over to VS Code and show you how easy it is for a developer to enable this community linter COP. And then I'll show you the page where the whole project sits and how you can check it out and maybe contribute to it. So let's head over to Visual Studio Code. You'll see that I have a small AL project here, and I'll be returning back to it a bit later. But right now, what I want to show you is if we go over to the extensions tab, and I already have the extension installed, but you could just simply search for it. The name is businesscentral.lintercop. It's the extension that I have on the slides. Once you install this extension, what you get is a new shortcut here at the bottom with the name AL COPS. And once you click on it, you can enable any of the 4 Microsoft provided COPs, and additionally, you can also enable a linter COP. Once you select the ones that you want to have enabled for you in this project, you click OK, and that's all a developer has to do to enable the linter COP. Now let's head over to the actual page of the project. You can find it on GitHub at github.com/stefanmaron/businesscentral.lintercop. And what you'll find here is the full source code to the analyzer. Under releases, you will find the compiled .NET library that you can then use in your pipelines, you can use in the VS Code. And in the README, you will find a description of all of the different rules that lintercop provides that can help your code be better, be of higher quality. Now, if you ever find any issues with the lintercop, you can just create them under the Issues tab. But additionally, what I would like you to check out is the Discussions tab. The Discussions tab is where if you have an idea what could additionally be created as a new rule but doesn't exist yet, you can check if the discussion was maybe already created, or you can create a new discussion, and if the discussion gets enough traction, it might be implemented as part of the lintercop. Okay, now let's get back to the presentation. So let's assume that you've now checked all of the 4 COPs from Microsoft, you've checked the community initiative, but you still have your own coding conventions, you still have rules that you would like your own developers to follow. What can you do next? This is where custom code analysis comes into play. Now, we're going to take a look how you can create your own custom analyzer. We're going to do that by going through the source code of our internal Companial COP that we use here at Companial. We actually published the whole source code a couple of weeks ago, and you can check it out. It can be a really good starting point if you would like to create your own additional rules, or it can also be just a starting point where you can kind of learn how that can be done. We're going to go through that source code in Visual Studio, and I'm going to show you what are the main points that you need to be aware of when you're creating a new rule. And finally, I'll show you how you can debug a rule. This part of the presentation is going to get quite a bit more technical, but I don't want you to get afraid by this part. My intention here is not to create a step-by-step guide how to create a custom linter. The idea is just to share with you that this is a possibility and it's really not that difficult. You really need to know just the basics of C# and you can start creating the rules to make your code review process faster. Before we actually go deeper into the code, I need to share two disclaimers with you. The first one is the support disclaimer. What I mean by that is officially, Microsoft does not support custom code analysis. Yes, the code analysis tool that we'll create will work in Visual Studio Code. And yes, it will work in the build pipelines. But there's no official documentation saying what's available, how you can do it, what happens in the next major release. But luckily for us, the whole framework for AL analysis closely follows the Rosalind linter framework, which some of you may know from the C# world. So if you're ever looking for, you would really want to look into more documentation, you can check what's in the documentation for Rosalind. And in most of the cases, it's the same case for AL analysis. The second disclaimer is about maintainability. And as I said, because Microsoft does not officially support custom code analysis, they don't care that they introduce breaking changes with each new major AL language release that they do. What that means is when you create a when you create an analyzer that's compatible with AL language 8, when 9 comes around, it's going to stop working. It happened to me when we switched from 8 to 9. It happened when we switched from 9 to 10. And I believe in April, it's going to happen again when we switch from 10 to 11. Now, it's a bit annoying, but the fix is really simple. All you have to do is, in April, what we will have to do is find the libraries on which our analyzer depends and include them again into our analyzer project and just rebuild the solution. And then the new analyzer can be used with the AL language 11. Okay, now let's head on over to the source code. First, I'll start with the repository for Companial cop. You can find it again on GitHub. It's at github.com/companial/companial cop. And you will see that the structure here is closely followed to the one that we saw in linter cop. You can find the full source code here. And again, in the README, you can find all of the rules that we implement as part of the Companial cop. We use Companial cop in addition to the linter cop, so it's usually the rules that are not in linter cop. We do try to create pull requests so that some of these rules will end up in linter cop, but some of them are probably not needed by the wider community, so they will stay only as part of our tool. Good. Now let's move to the Visual Studio, where you will end up once you actually clone the Companial cop repository. Before we go any deeper into the actual rules, let's start first with the dependencies, which I've talked about a minute ago. You'll see that the project Companial cop Analyzer has a couple of dependencies, a couple of assemblies, and most of these are a non-issue. But the ones that break with each new major AL language release are these three: Microsoft Dynamics NAV Analyzers Common, Code Analysis, and Code Analysis Workspace. So as I said, in April, we will have to find these three libraries in the AL extension folder, bring them back into the project, build the project again, and everything should work as it did before. Now on to the actual rules. In Companial cop, each rule has its own C# class. Today, I will be showing you the example of rule number 13, which is called tooltip punctuation. And you can probably already tell from the name, we created this rule that whenever we have a tooltip, it should end with a dot. If it doesn't, we're going to throw a warning. But before we go into the internals of the class, we first, when we're creating a new rule, we have to create a new diagnostics descriptor. we do that in the file called diagnosticsdescriptors.cs. You can think of diagnostics descriptor as just a placeholder for the code of your rule, for the title, for the description, for the default severity, and this is where you define it. You can see that each of our rules has a dedicated diagnostics descriptor. And again, I'll be going through the rule number 13. The easiest way when you're starting is just to pick one of the existing ones, copy it, paste it, and that should then change whatever is different for your specific rule. Obviously, you start by changing the name, but then in the parameters, the first one is the code of the rule. It consists of a prefix and a sequential number. If you will be changing the prefix, something to pay attention to is that prefix always needs to be exactly 2 characters long, not 1, not 3. Otherwise, you will have issues when you try to use this analyzer within the pipelines. So obviously, first you would change you would increase the code of your rule. And next, you have to add the title, the format, and the description of the rule. You'll see that all of our rules actually do that through the resource manager, which means that all of our strings that we use to display to the developer are actually in this file here, Companial cop analyzer.resx. And when we define them in the descriptors, we use dedicated procedures that get the strings out of the resource manager. But today, to keep this presentation a bit lighter, I will show you that you can just have the title, description, and format as hard-coded strings here. So in most of the rules, these are the same, but that's not always the case. Now there's a couple of other parameters here. I won't go through each and every one of them, but the one that I would like you to pay attention to is the diagnostic severity. This is the default severity of a warning. So here you define when something happens, should that be an error? Should it be a warning? Should it be an info? Or it can also be hidden. And all of that can always be overwritten by a rule set file, just how most of you are probably already aware when you were disabling or enabling Microsoft rules. So now that we have the diagnostics descriptor, let's head over to the actual class. Okay, so now we're in class rule number 13, tooltip punctuation. When you're creating a new rule, the same thing, I'd say find a rule that is most similar to the one that you're trying to create and copy it and start changing it. But still, I would like to give you a general overview of what parts are actually needed here. So when you create a class, it needs to inherit from a diagnostics analyzer class. And there's 2 functions that you need to override within that parent class. The first one is supported diagnostics. This is simply a way where you have to tell what kind of descriptors can the compiler expect from this class. Here we just specified you can expect a descriptor for rule number 13, because this is what we'll be throwing throughout our analysis. And the second one that you have to override is the initialize. This is the one that's more important. In the initialize is where you actually subscribe to the compiler events. And this is the syntax that you use for subscribing to events. Let me first show you how many different types of events there are. You can register syntax node action, you can register symbol action. Maybe let me first explain how does this work. So whenever a compiler finds a syntax node, we want to register a specific action that will handle that syntax node. But since there's so many different types of syntax nodes, you have to filter it down. So you specify, okay, I would like to register an action anytime, I would like to register an action anytime a compiler finds a syntax node of the type that I will specify. And the same goes for symbols and the majority of other events here. Now, if you would like to read more of the documentation on this part, these events are exactly the same for the Rosalind analyzer, so you can find all the documentation in the Rosalind documentation. Okay, now let's get back to our example. So what we're trying to do here is we want to register an action whenever a compiler finds a syntax node of type page field or of type page action. And when it does find a syntax of type page field or page action, we would like it to execute an action called analyze tooltip punctuation. And if we check what is this analyze tooltip punctuation, it's just a function that I have defined here in the class. So let's go over this again. On initialize, what you do is you subscribe to compiler events. You do that by registering an action whenever a specific syntax node is found. Now let's get a bit deeper into what does the analyze tooltip punctuation actually do. You will see that each of our rules usually starts with these two lines. What these two lines do is they check if the containing symbol is obsolete or if the containing object is obsolete. So in our case, if the page field is obsolete or if the whole page is marked as obsolete, we won't be doing any analysis because that's going out of our code base sooner rather than later, and we just don't care. Once that's cleared, what we do is we try to get a property out of that syntax node. We try to get the property that's named tooltip. And if that tooltip is not null, meaning that if the page field has a tooltip defined, we get the tooltip's value. And then we simply compare if the tooltip value doesn't end with a dot, or if the tooltip value doesn't end with a dot and a closing bracket, then we're going to throw a warning. We throw a warning by using this syntax here, report diagnostic. And all we have to pass into report diagnostic is which descriptor will we be using. This is where it takes out the description and the title for the rule, and the location where would we like the squiggly line to appear for the developer. And once you have that, once you created your condition, and when the condition is met that you would like to raise a warning, all you have to do is build the solution. You do that by going under build and build solution. And it should be done. Yep, build succeeded. You probably might not be able to see this part here, but this is the important part. This is the path to where Visual Studio actually outputs our analysis tool. This is what we're going to use to set up in Visual Studio Code. So now let's head on over to Visual Studio Code. Here it is, back into our project. And you can see that I have a page here that has an action that has a tooltip, and the tooltip does not end with a dot. And currently, that's not a warning because the analysis tool is not yet enabled. So how do we enable it? You could enable it either in the user settings, you could enable it either in the workspace settings, but personally, whenever I'm developing rules, I just create a settings.json file within the .vscode folder in the AL project, and this is where I put my settings. Which settings do you need? You're probably already know this because these are the same settings that you need to enable when you want the code cop or the app source cop. So it's enable code analysis set to true, and then you specify which code analyzers would you like to run. So all you have to do is specify the path to your analyzer DLL. This is the exact same path that we saw earlier in the Visual Studio. So I'll just uncomment this. And you'll notice that as soon as I save the file, it already shows me additional warnings that come from this analyzer. But if that doesn't necessarily work, it sometimes can happen, especially on bigger projects. You can just simply reload window, and then the VS Code will pick up your additional analyzer and start analyzing everything. Now, this might take a minute because I have a lot of extensions in my Visual Studio. So let's just wait a bit for it to load everything up. Okay, so now it's discovering the objects. There we go, loading the workspace, preparing project, and any second now we should be able to see the warnings. There we go. So now we see that there's an additional warning under the tooltips. You can see the squiggly lines here. If I move my my mouse over it, you'll see that it says tooltips should end with a dot. Now, before we go back to the presentation, I'd like to show you one more thing, and that is how you can debug a rule. If you're coming from languages different from AL, this won't be anything too new for you, but still I'd like to share this because it's a bit different than we're used to when developing in AL. So I'll set a breakpoint here, and we cannot just go under debug and start debugging because this whole project is set up to create a library. It doesn't create a program. So what we have to do is we have to attach to a process that is using our library. And we do that by using the function attach to process. Now, the process that you'll be looking for is called Microsoft Dynamics NAV Editor Services Host. This is the process that is running in Visual Studio Code when it's analyzing code. So let's attach to it. And now let's get back to Visual Studio Code. There's two ways how you can trigger the breakpoint. Either you would start building this solution, or you can just make a simple change in your active editor. For example, I will create a new line here. And you will see that immediately the focus switched back to Visual Studio and the trigger has been hit. And here you can now debug the rule. You can start exploring what does context have to offer, what does the syntax node have to offer, what are the properties available, and you can find the things that you need to start creating your own rules. I think this is even the debugging here is even more important just because we don't have any official documentation that would help us to create the additional rules that we would like. Okay, that's enough of the code. I'll just stop the debugger here and let's get back to the presentation. Okay, now we've seen how we can create the .NET library. How do we integrate it with development workflows? We've already seen how it can be done in Visual Studio Code, but additionally, I'd like to share the best practice that we use here at Companial. Anytime that we start a project, we also create a workspace, and in the workspace settings, we already define which analyzers we would like to use, and we define the rule set if we would like to turn off any specific rules for that specific project. So then anytime any developer joins that project, all they have to do is open the workspace and they immediately get the warnings that are required to follow on that project. On the other side of things, in the build pipelines, luckily BC Container Helper supports custom code cops out of the box. Both the compile app in BC Container and the run AL validation functions have a parameter called custom code cops, where we simply have to pass in the path to our analyzer, and the pipeline compiler will raise those warnings as well. If any of you are using ALGO for GitHub or ALOps as your CI/CD provider, I didn't play around with those too much, but I did go through them just enough to see that they both have settings where you can specify additional code cops and include them into those pipeline runs as well. Now, I'm going to show you the use cases where we at Companial have really benefited from having the custom code analysis enabled. We're going to see one runtime error, a couple of maintainability, extensibility, readability improvements, a couple of coding conventions, and some nice to haves. Let's start with the runtime errors. Let me say that most of those are caught by Microsoft, but there is one that they skipped. And when we did report it to them, they said that they will fix it in the future, but we needed it sooner than the future. So I'll give you a couple of seconds to look through this snippet and try to figure out what's the issue here. The code's in black and white because this is exactly how you see the code when you're trying to do the code review on DevOps. The issue that we had internally wasn't exactly with the customer ledger entry, it was with the custom table, but the underlying issue was the same. So when I went through that code, it looked all fine to me, but then when we tried running it, this is what we got. The sales LCY field in the customer ledger entry table must be a flow field. In our exact case, the problem was the developer created a field, marked it as flow field, created the calc fields, and then later on figured out that, oh no, it actually needs to be a normal field, but forgot to change it in the set auto calc fields. So that's why we implemented a rule that checks that all of the fields in the set auto calc fields should be either flow fields or blobs. If it's not, it's going to add a squiggly line and the developer immediately knows, oh, okay, I need to remove the field from here. Otherwise, it won't work. Next, we have the maintainability improvements. These are especially beneficial when you have to return to your code or to somebody else's code 6 months later or 12 months later when you have no idea why something was written the way it was. The first example here is with the commit statement. Commit is quite a powerful statement, and yes, sometimes we do need to use it. But the problem is, when you come later to it, why was it used here? And this is actually a rule that comes from the linter cup. It does, well, exactly what it says. Commit needs a comment to justify its existence. And since we started using that rule, it's much easier to tell, oh, this commit is here because, well, here's a comment. Okay, I get it now. The second example, I don't really even know why this was ever allowed, but it's about internal methods having implicit parameters or optional parameters. If you take a look at the snippet here, it looks simple enough. You initialize the customer record, you assign a number, you assign a name, and then you insert it. But then 6 months later, you get back to it and you start thinking, did the developer want to skip the insert trigger, or did they just forget to specify the parameter? We don't know. They don't know. Nobody knows. And that's why we created this rule that all internal methods must be invoked with explicit parameters. It's done for insert, modify, delete all, and I think current page update. That way we can track the intentionality much better. If somebody wants to skip the trigger, write false. If you don't want to skip the trigger, write true. Next up is the extensibility improvements. This might be a hit or miss for you, but for us, they really do help whenever we start a new project, especially if that project is targeting app source. What we did is we added rules that force us to create each procedure as either local or internal, and that all of the objects need to be set to internal and non-extensible. We did that because to say that the obsolescence process is annoying is an understatement, especially at the start when you know that nobody's actually depending on your app. And I do agree that at some point you do want your app to become extensible. So when that is still on a case-by-case basis, we do that by just turning off the rule by using Pragma, as you can see here in the second screenshot. And when the app comes into maturity and it's mature enough that it's going to be much more extensible, we simply turn off those rules, and then it's up to the developers to pay more attention. Okay, should this procedure be internal or external? Next, we have readability improvements. This one was another one that I really liked once we actually created the rule for this. Take a look at this snippet. We have a procedure, a global variable section, a trigger, a procedure, a trigger, a procedure. It's a mess. Now, why is it a mess? I don't know. Maybe the developer didn't care. Maybe it was due to some merge conflicts. It's not the correct ordering. It's confusing. That's why we implemented a rule that on all of our objects, we want to have ordering like first global variables, then triggers, and then methods. And whenever a developer would place a procedure or a trigger in the wrong place, the whole section would get a squiggly line saying, sorry, the ordering is not correct. Please fix the ordering. Next up, we have the coding conventions. These are the most, let's say, either project specific or partner specific. In the examples I have here, I was working on a project where partner was using something similar of a Hungarian notation. For those of you who don't know, the Hungarian notation is where you prefix the global variables with a G, the parameters with a P, the local variables with an L. And all of that was really hard to track during the code review process. So we just added the rules. Okay, if you find a global variable that's not prefixed with a G, raise a warning that it needs to be prefixed. And the same with the capitalized exit statements, which happened at the project, which I've told you about at the very start of the webinar. And finally, we have a couple of nice to haves. These are the parts where it's not going to make your code any more maintainable. It's not going to make it faster, but it does standardize it. On the left, you can see the example of two procedures. One is defined with a semicolon at the end. The other one isn't. There's absolutely no difference between these two. But at some point, we just agreed, let's all follow the same approach. Let's not have semicolons at the end of our procedures. So we just added a rule that says, whoops, you added a semicolon, please remove it. And on the right side, it's about the empty captions in the enum values. Those empty captions always get added to the xlif file, but nobody's actually translating the empty captions because they're empty. So we added a rule that all the empty captions must be locked. So they aren't added to the xlif file because I think we can all agree that the xlif file has already way too many lines as it is. So in conclusion, what do I want you to take away from this webinar? First off, turn on all of the Microsoft provided analyzers. They really do help catch bugs way before they slip into production. And next, explore the community-driven initiatives. See what's already available there and see if that might fit your development needs. And once you're done with that, I'd like you to start finding and defining your own coding conventions. What are the rules your developers should follow? And when you define them, start automating them. You will find issues faster, you will standardize your code, and you will accelerate your development process by quite a lot. And once you have those rules, I would invite you to contribute back to the community. If you've implemented a cool new rule, open a pull request to lintercop. If you only have a really good idea, open a discussion and let's see where that leads us. Finally, I would thank you all for your attention today. If you have any questions, I invite you to submit them under the Q&A section on the right side. And if there are more questions that we won't be able to answer, well, in this Q&A session part, feel free to reach to us either via email or connect with me through LinkedIn, and let's see how we can help you automate your code quality. Now, just before I open the Q&A session, I'd like to take a quick minute to explain what we do here at Companial and how that can benefit you, the partners. This is actually the area where I work. I work in development services for Business Central. And essentially what we do is we cover or extend partners' capacity. The two main benefits that I see that we kind of provide to you is, I think we can all agree that we would like to have more developers. If we could find more developers, we would have more developers. And here we can help you. If you would need more development help to complete your projects in a more timely manner, this is how Companial can help. And on the other hand, because Companial is working with a lot of different partners from all over the world, we started amassing quite a big knowledge base and best practices on topics like automated testing, integrations, security, and we can help you raise your already existing solutions to the next level. If you'd like to know more, feel free to explore our webpage, companial.com, and get in touch.